Hi guys, we're back with answers to page 7, this is solving quadratic equations. When you solve a quadratic equation, first of all you need to know what a quadratic is. A quadratic is a function where your degree is 2, and degree is the highest exponent in the expression. So here we have x squared plus 7x plus 12. You see that 2 is the highest exponent, therefore it's a quadratic equation. You also know it's an equation because it's equal to something. And in order to solve these, they must be equal to 0. If it's not equal to 0, you must manipulate it so that it can equal 0. Also, there's several ways to solve these. If you can factor the quadratic, like we just spent time doing, and you're very comfortable doing that, then you can save yourself a lot of work sometimes. So I'm going to do some of these by factoring. If you can't factor it, or you're not comfortable using factoring, then you can always use the quadratic formula, which I'll write over here on this page. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now there's many songs for that. There's Row Your Boat song that Mr. Byler knows really well. There's a lot of YouTube videos, so if you're having trouble remembering it, you could check that out. I'm not going to sing for you here today, but in class maybe I will. But basically this comes from the fact that a quadratic equation looks like ax squared plus bx plus c equals 0. A is going to be the number in front of x squared, b is going to be the number in front of x, and c is going to be the number without a variable. It's called the constant term. So we're going to apply that throughout this as well. But we'll start with number 1. Number 1 is factorable because I can look and say I have two terms that multiply to give me 12 and add to give me 7. And those are positive 4 and positive 3. So what I'm going to do is go ahead and factor that expression. And then once I factor that expression, I just take the opposite value. So this says x plus 4 equals 0. So therefore, x has to be the opposite of that to give me 0, which is negative 4. And then we apply the same logic. This gives me negative 3. Notice also that quadratics have two answers because the degree is 2. And that works for all polynomials. If I have a degree of 5, I'm going to have 5 answers. If I have a degree of 10, I have 10 answers. So here I have a degree of 2, I have 2 answers, and they're negative 4 and negative 3. Number 2, we see that this is not equal to 0. So what we're going to do in this case is we have to make it equal 0. So what I'm going to do that is subtract 10x from both sides. When I subtract 10x on both sides, they go away on the right, which gives me 0 on the right, which is what I want. And on the left, I have 5x squared minus 10x. I just rewrite the problem. Now I see that I can actually factor out a GCF. So this has a 5x in common. So I'm going to take the 5x out, and I get left over x minus 2. Now when I do this, I can see here that 5x has to equal 0, which means that x could be 0. And I know that x minus 2 equals 0, which means that x could be 2. So my answers are 0 and 2. Now if you look at 3 also not equal to 0, so I'm going to start by subtracting 15 from both sides. That's going to give me 2x squared plus x minus 15 equals 0. And now instead of trying to factor this, I'm going to use the quadratic formula that we talked about over here that many of you will be very comfortable using. So I'm going to identify a, b, and c first. A is 2, it's the number in front of x squared. B is 1, it's the number in front of x. There's a little secret 1 here. And then c is going to be negative 15, which is the number by itself. And now I'm going to plug these into the formula. So I get x is equal to negative b, so that's equal to negative 1 plus or minus the square root of b squared. So that's 1 squared minus 4 times a, which is 2, times c, which is negative 15. All of that over 2 times a, so 2 times 2. I'm now going to simplify this, so I get negative 1 plus or minus square root. I take the square, or 1 squared and get 1. I multiply negative 4 times 2 and get negative 8. Multiply that by negative 15 and I get positive 120. Then I divide that by 2 times 2, which is 4. I simplify this further. I get negative 1 plus or minus, I add the 1 and the 120 and I get 121 under the square root, and then I get 4. Now the square root of 121 is 11, so I simplify that, so I get plus or minus 11 over 4. And then I go ahead and do the plus or minus. So when I say do the plus or minus, I mean do the plus first and then do the minus. So what I do is I do negative 1 plus 11 and get 10. 10 divided by 4. So 10 divided by 4 simplifies. So I take the 2 out. So the first answer is going to be, like I said, negative 1 plus 11 over 4, which is 10 over 4, which reduces to 2.5, or 5 over 2. So that's one answer. My second answer is going to be over here, and it's going to be negative 1 minus 11 over 4, which is negative 12 over 4, which reduces to negative 3. So my two answers are negative 3 and positive 2.5. This formula works for any quadratic, so if you get really good with the formula, it might save you some work. I'm now going to do number 4 using the same formula. Your A here is negative 1, your B is 2, and your C is 10. So what I'm going to do is because I'm close to running out of room, I'm going to go ahead and just plug those in and skip that first step. So here I get x is equal to negative 2 plus or minus square root of 2 squared minus 4 times 1, or negative 1, times 10, all over 2 times negative 1. I simplify this and I get negative 2 plus or minus the square root of 4, that's 2 squared. Negative 4 times negative 1 is 4 times 10 is 40. So I get 4 plus 40 over negative 2. And I simplify this and I get negative 2 plus or minus the square root of 44 over negative 2. Now, 44 doesn't simplify, it's not a perfect square, so I have to do the simplifying radicals. So what I need to do is look for a perfect square that goes into 44. That number is 4, so what I'm getting here is I take the square root of 4 and bring it out. So I get negative 2 plus or minus, and I'm going to continue over here. I take the square root of 4 and get 2, and I'm left with 11 underneath because 11 times 4 is 44. All of that is divided by my negative 2. So here, my final answer is going to be negative 2 plus or minus 2 times the square root of 11 over negative 2. Now I notice that I can divide each of these by negative 2, so I end up getting 1 plus or minus, and I divide these and I get negative 1 times the square root of 11, or just the square root of 11. And that's going to be my final answer. Now, in order to understand this, you have to understand how to simplify radicals. There's another video on that on another page of this packet. So if you're confused, you can look that up as well. If we look at number 5, we see difference of squares pattern. So I'm going to factor this and not use the formula because I know that this easily breaks down into x plus 4, x minus 4 equals 0, which then allows me to get the answers of negative 4 and positive 4, which is way quicker than using the formula. But then this last one, I'm going to use the formula because that seems to be quicker than trying to do the factoring. So once again, I'm going to do identify your A, your B, and your C. Your A is 2, your B is negative 3, your C is negative 3, and then you plug those into the formula. So you get x equals negative B, so that's positive 3 because it's negative negative 3. This is plus or minus the square root of B squared, so 3 squared is 9. Minus 4ac, so 4 times 2 times negative 3. And that's all going to be over 2a, which is 2 times 2. I simplify this, and I get 3 plus or minus the square root. I get negative 4 times 2 is negative 8 times negative 3 is going to be my negative 9. Sorry, negative 8 times negative 3 is 24. So I'm getting 9 plus 24 here over 4. I simplify that, that's 3 plus or minus 9 plus 24 is 33. And what ends up happening here is I look to try to simplify 33 and I can't, so then I can just leave it in this form, which is kind of nice because I don't have to do any extra work. Once again, these problems are not easy. If you have questions, let me know. You need to master the quadratic formula so you can be successful later on in this class.